So if you can understand the previous example well, so we'll go deep into a complete example of classification. So we will use the supervised learning, classifications, and then we'll use the deep learning approach to do a computer vision example. And in this example, we'll go deep into the calculation level, deep into the structure, etc., etc. So this example is a complete classification example, how the AI is used, and then what is the step 1, step 2, step 3, step 4, etc. that I can analyze. I can use the computer vision to detect whether it's a cat or it's a dog. So repeat and repeat, and then image classification in by using the neural network. So somehow it's just like here, right? So they have multiple layer. So there is layer 1, 2, 3, 4, multiple layer, and then in each layer there are some feature. So feature here and feature there is just like I would say that a door. If you bingo the feature, so you pass to another door. If you bingo the feature, you pass to another door, etc., etc. So in each layer, so there are lots of door, there are lots of feature. And then if you here say that if there is a cat image, and then you go to a trained image, it bingo the cat feature 1, bingo the cat feature 3, bingo the cat feature 4, 5, etc. And then we come up with a percentage. So how many door that you can pass through, how many door that is bingo, then I can say that, hey, I have confidence to say that this image is a cat, and then the output will return cat. So similar to your previous example, we are not looking for 100% correct, and then I will say that this one is cat. Perhaps I will accept 70% or 80% correct, then I will identify this one is a cat. So how to train up the layer, okay, or the door, the feature of the machine learning model. So somehow again, so we need the training data set. With the training data set, and then you put into a machine learning algorithm, then they will learn the feature of what is cat feature, what is dog feature on the photos by using the vision, what is the feature of mug, what is the feature of head, etc. And then when you have a new photo of the cat, and then ask the model, because I know the cat feature, so I can say that, hey, by recognize this image, by recognize this picture, I can recognize this one is a cat. Okay, it's a cat, 100% cat. So I will, I have downloaded some data set of cats and dogs, and then I will use my face and then recognize and tell you the detail how to define a cat and a dog. So yeah, it will be fun, and then we'll try in later situation. But within these lessons, yeah, please use your brain to frame that, hey, how by the visions, what is the feature of cats and then what is the feature of dog by your brain, by your IQ, by your university student, right? So honestly, without a machine learning model, so what can you find the common feature of a cat, or what can you find a common feature of a dog? Okay. So if you want to do the image classifications, honestly, you have to provide lots of the training data, and then all the data should be labeled up. So we will do a Google teachable machine example, and then look at how we can prepare this sets of question and these sets of training data set. Okay. So yeah, learning is the rules of machine learning. Okay. So yeah, training data is I would say the golden rules of the machine learning. So this graph appears again, right? So we repeat. So in this course, perhaps we will see lots of the graph is repeat. So we are brainwashing, okay? We are brainwashing you. So you can put a star here to understand how a machine learning model can fully understand the feature of an image. So the algorithm here is called convolutional neural network, CNN. This is the algorithm name, AI algorithm name. You can have different algorithm. So there are lots of AI model, AI algorithm. And then CNN is only one of them. So this graph is easy to understand. So you have lots of the input data, and all the data, they are car. Okay, they are car. We put into different layer. And then different layer, they will learn the feature of a car. So can you see that? Just like a door, right? So if a door pass through one, pass through one, pass through one, pass through one, so they become smaller, 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 and smaller. We want to, if the image becomes smaller and smaller and smaller, we want to find out the abstract pattern, abstract common patterns of a car. So when they pass through one by one, so the details of the image will be decreased. Details of the image will be decreased. And then the only special feature, image feature, will be filtered out, filtered out, and filtered out. So after we filter out this kind of the feature learning, find out the feature of a car, and then we will have a vector here. So vector is the, we will say that feature 1, feature 2, feature 3, feature 4, etc., etc., etc. Per house, I will say example. So per house, here we have 100 this kind of feature. So we will calculate how many feature is bingo. Okay, so maybe within this 100 feature, we have 99 are bingo. So this 99 will become the confidence to define, hey, this one is a car, or this one is a truck, this one is a van, or this one is a bicycle, etc., etc. So this is the machine learning how the image go through a machine learning, and then they can identify, hey, this one is a car, this one is a truck, this one is a van, etc., etc. By looking at this abstract graphic, perhaps you have difficulty to understand, what's going on in the middle part, what's going on in the feature learning. So the next one will be a more easier to understand. So this image provide a better understanding. So how the feature of a car is captured, and then where is the door, and then how the door is bingo, bingo, and bingo. So here is the image of a car. So it passed through a bigger, I would say bigger, we call it lower level feature, and then lower level feature will analyze a small part, small part, small part, small part of this image. And then there are some common patterns of all the cars photo. So if this image, this feature bingo, we say he can pass through one door, and then this lower feature will be combined together. So can you see that for lots of the lower feature, you can find, hey, there is a wheel, there is a wheel, there is a wheel. So those are the feature, middle feature of a car, and more this kind of the small elements will be combined to a bigger element. So they will have some abstract. See that? This one is the abstract finding, abstract image feature. So you can see lower level feature, we're only looking at a small part of a car. Middle level, bigger one. High level, bigger and bigger one. So we can design lots of this kind of level of feature, and then when you pass through the different layer, so more and more parts of the image will be analyzed. So that's why the layer, they become small, 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 small. So means that if you try to make, for example, Peter here, Peter, uh, we have a high resolution of image. If you make it small, 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 and smaller, and then Peter, the face will become more blur and more blur and more blur until a level you can still find that, hey, Peter is a human, or Peter, the bird image, the small image, Peter is still a human, and then they will classify Peter is a human. So this is called the machine learning. This is how the CNN convolution neural network is working. Of course, different AI models, they have different layer, but for the CNN is one of the most powerful and most useful machine learning feature to learn the fraud. So yeah, you say that you are not from mathematics, but you are OT and PD student, right? So definitely you have studied biology before, right? So you can pause here and think about a questions when we are a baby, okay? When we are newborn baby. So there is no information in our brain. We have lots of the cell brain, right? So all the cell brain, the nervous, so they are connect with the nerve. So all the cell brain, they are interconnect with each other, okay? But honestly, there is no information inside our brain. So we do not know that, hey, this is mommy, this is milk, this is milk bottle, this is hungry, etc., etc. So all this kind of image is put in our brain after we was born. Okay, we were born. Okay, so my question here is, suppose that you, when you feel hungry, you cry. Okay, hungry, and then you cry. But after learning, when you see a milk bottle, then you stop crying. So this is a learning process. Milk bottle, and then you know this is food, and then I know that I will not be hungry, and then I will not cry. So that is a learning process. My question is here, if you have learned the biology, so can you describe how this kind of information is put inside my brain, and then how I can learn when I see a milk bottle, and then I will stop crying. Pause here and then think a while. Have you paused? Whatever. So somehow, let me explain. So there are lots of empty brain cell, empty neurons inside your brain. So here, so you have the vision part, and then when you see a milk bottle, here, the image of a milk bottle will be put inside one of your cell brain, inside one of our neurons. And then there is another here, vision. So there is another called hungry neurons, hungry brain cell. So if you simulate these two brain cells a lot, for example, you see the milk bottle, then I will stop crying. You see the milk bottle, and then I will stop crying. Milk bottle, I will stop crying because I feel full. I know that this one is a food, right? Milk bottle, and then I will stop crying. So the nerve here will be stimulated, okay? And then this stimulate connections, so the chemical will be increased. The chemical level will be increased. So when the chemical increase into a certain level, so milk bottle, the brain cell, and then also the not crying, that means I'm full, I'm not hungry. This one are connect with each other. So when you see the milk bottle, you stop crying. When you see the milk bottle, you stop crying. So they are interconnect. Their chemical level is increased into a certain level, and then they interconnect with each other. That is the learning process of our brain. Got it? Got it? So let me repeat. So here is our brain, and then our brain is full of neural networks. Okay, neural network. Okay. Inside the neural network, so we have lots of the neurons, and then each neuron is a brain cell. Most likely when we were born. So when I was born, lots of our these brain cells, they are empty. When we have the simulation from the outside, we'll put the information into our brain cell. For example, I put milk bottle here into this brain cell, and then I put another not hungry, or I feel not hungry, and then stop crying. I feel another reaction here. So when you see the milk bottle, I know that I have food. When I see the milk bottle, I know that is a food, and then I will not cry. So they will have the chemical inside. When more and more chemical is here, so they will up to a certain level, and then I will say that they are interconnect with each other. Okay, they interconnect with each other, and then I know that they have the relationship. And then when I see the milk bottle, I will stop crying. That is our learning process. Okay, it is easy, right? So if you have learned biology, I guess this kind of the information you have learned before. So because we are learning AI, and then you are I'll call it interdisciplinary, and then you have also learned the mathematics. You fully understand this part, correct, right? Pause here again. Think about how we can change this kind of learning process into a mathematical representation. That means how I can use a formula to represent this kind of learning process. So have you paused and then think a little bit how it can be presented in mathematical way? Honestly, this one is not very difficult. All of us have learned this equation. The equation is called linear equation. Y equals to mx plus c. Y equals to mx plus c. So the situation is right there. So it's just like we use different knobs. It's our cells inside the brain, neurons inside the brain. And then all these kind of knobs, they are interconnect with each other. And the equation to connect with each other is linear equation. Y equals to mx plus c. M is the slope. M, when you get similar with each other, the slope will be increased. So when the slope increase to a certain level, that means this line, this nerve, or these two neurons, these two brain cells, they are connect with each other. Okay, so honestly, neural network is here, and then CNN, or we call it artificial neural network, is trying to use linear equation to simulate the whole thinking process, to simulate all the things. So all the neurons, they are interconnect with the nerve. And then all this kind of thing is just the summarizations equations of all the linear equations. And then when you get the input, simulate each other, the slope will be increased. When the slope increases to a certain level, we say that they have the relationship between these two cells. So here is the input, and here is the output. Here is the milk bottle. Here is I'm not hungry, stop crying, etc., etc. So this is how, when you have lots of the input data, when you have lots of the simulations, and then they will activate the slope level m, y equals to mx plus c, the m slope level into a certain high level, and then we say they are interconnect with each other, and that is artificial neural network. So yeah, let's go deep and deep. So this is one of the examples that will go deep into the calculation. For example, here we have two input. So x1 may be the milk bottle, x2 may be the handkerchief, okay? Y not crying. So here, when we have the x1, the value is 5. That means it looks like a milk bottle. X2, it looks like a handkerchief. So if you are parents, so most likely you will always think that there is a handkerchief, and then combine with the milk bottle, because they will, the baby will mix all the things very dirty. So mostly handkerchief and milk bottle, they will appear at the same time. And then you have also Y. So Y is not crying. And then we want to find out the relationship of this lab work. So if I can recognize this one is milk bottle, more higher value. So not crying will be higher. So 1 will be not crying. So yeah, you have the x1, x2, and then you have the output Y not crying. So at the very beginning, when we are newborn baby, yeah, we are really lovely. So all the things in your brain will be random. Okay, will be random. Maybe you will randomly become a genius, or randomly become a, I don't know. But all the connection inside your brain, they are random. Okay, so here we also have the random number 0.8, 0.7, 0.2, negative 0.3, etc., etc. We have the random number. And by looking at each neuron and then output, so each neuron, they are connect with the linear equation. That means connect with the nerve. So when they have the simulation, this one is true, this one is true, this one is true, the slope will be increased. So all the linear equation, so there is a slope. So here the equation, this line will be y equals to mx. Forget about the plus c first. Forget about y interception. Because y interception will be more difficult, so forget about it. So here y equals to mx, so this one is w1 times x1, and then you have another input from another brain cell of your eye. So this one is x2, so here will be w2 times x2, and then here you have the w3 times x1, W4 times X2, and then W5 times X1, W6 times X2. So this one here will be a summation of all the linear equation. So for h1 here is the summation of this linear equation and then that linear equation. So the h1 will equals to w1 times x1 plus w2 times x2. So that is the situation. And then another one, so you have the h2. So h2 will be h2 times w3 times x1 plus w4 times x2. So those are the summation of the linear equation. And here you have y equals to summation of this one and this one. Always remember that when you are working with a linear, when we are working at a neural network, so all the knobs here, they are interconnect with the linear equation. So all the knobs, they are connect with each other, just like all the things in your brain. So when you are a newborn baby, so all the your cell brain, they are interconnect with each other, nothing missing. Okay, but of course they have the random value. So after the random value, and then after you have one input of the x1 again x2, right? So you can calculate estimated y. Always remember that that's estimated y is different from the real y. Okay, of course, right? So you want to find the relationship of all the w1, w2, w3, and 4. And then now I say that it's just a random number. So if the random number here, and then you can formulate the whole network, find out the equation with the random number in the first one, then it will be, yeah, you bingo. You are the genius. So all of your brain cells, they are interconnect with each other. But honestly, it's really fair. So usually this kind of random number cannot help you to understand all the things inside the world or understand all the things very good inside inside the real world. So you have the learning process, and then the learning process is tuning or is updating the W1, 2, 3, 4, 5, 6, updating this value until all this value can formulate a error that is relatively small, and then we say that we have learned this x1, x2, and y they have relationship or not. So that is called neural network. Okay, that is the manipulation of neural network. Yeah, just like here, so you have the W1, W2, W3, W4, W5, W6. Assign the random value into the equation. Calculate the assigned random value with your x1 and then the x2. Okay, x1 and then x2. So you can calculate h1, you can calculate h2. So after you calculate h1 and h2, and then you have the y. Okay, y definitely is not equals to the real y. So here our estimate y after the whole calculation, it will be 0.82. So don't worry, I will not ask you always to use your calculator to do this kind of calculation. I will upload an Excel, and then you can play with this kind of number. So the estimate y here is 0.82. Not too bad, right? Not too bad. So compare with the real y is 1. So 0.82 is only 18% error. So it's 0.1x, right? 18%. So it's not really bad. But honestly, if you think a little bit more, so this value, so it's by random. So maybe the error is big, maybe the error is small. It's all by random. It's all by your luck. So don't worry. If when you were born, if the random number is not so good, you can still improve your random number by learning. Okay, so that means you have the second one, you have the third one, you have the fifth one, etc., etc. You can learning until this one, the real y and the estimate y for all the input data, the error is more or close to each other. So if you still remember the confidence, right? So we say it 70% confidence that we are say acceptable. But honestly, if the formula is so simple, it's just two input and one y output, right? So definitely we can push the error into 0.0001, okay, 0.001, or even we can fully compile this network. So only two input and one output is easy to find the relationship. So that is the learning process. You still remember the learning process of a neural network is tuning the slope, okay, tuning the slope. And then until we have the perfect combination of the slope that can represent the relationship of x1, x2, and also the y. Okay, that is our tuning process. And then, yeah, you say that the tuning process, right? So how can I tune the values? So honestly, the biggest number is more responsible for the error. So we will start from the biggest number first. So we will use the error and then go back to all the W1, W2, W3, W4, W5, and W6. The biggest one, the slope will change more. And then if the value is more, so the slope will change a little bit, a little bit, a little bit. So that is the situation. So until this training slope finish, then we say we have the perfect combination of the slope, and then we find the relationship of x1, x2, and also the y. So what is the error of x1, x2, and y? Y is 0.18. Okay, so we have calculated. So we have the, exactly remember, x1 should be 0.7 and the x2 should be a negative 0.7, something like that. So you can check. So we time here and then find out the number. So x1 is 0.01x and then x2 is negative 0.126, right? So if we take the absolute side, and then definitely this number will be bigger. Okay, this number will be bigger. And then x1 is more responsible for the error. So x1 will tune bigger. Okay, for example, both of them x1 and x2 is like that. x1 will move more, x2 will move less. So they will randomly rotate a little bit, randomly change the slope a little bit. And then the h1, h2 error will go back to the w1, w2, w3, w4, etc. And then they will have a new weighting. And then when you have the new weighting, you put the x1, x2 into the equation. And definitely now your second one, the calculation of your second one, this one, the error of the y will be less. Okay, maybe it will be 0.16, maybe 0.15, etc. So we don't know because the tuning here is also random. It's also random. But the biggest value, they will tune, they will have rotate more. The last value, they will rotate less. Okay, so until we have many ones, and then we find, hey, this one, the error is close to 0, and then we say that, we have the perfect relationship between the x1, x2, and y value. And of course, the linear network is not so simple. It's not only by the linear equation. So yeah, the very beginning is the linear equation, the weighting slope times the input, the relationship of slope and then input. And then we have the summation to summate all the information together. Then we find that we should put some activation function to say that this one is not a pure linear relationship. It should be a non-linear. Because yeah, I will make an example, right? So if you have studied the computer science before, and then we always say that, hey, we use a input number, and for example, the temperature is above 20 feet, we say it's hot. If it's below 20 feet, then we say it's cold, right? But why 20 feet, right? Why 20 feet? So someone will say that, hey, I feel cold when when the temperature go to 22, when the temperature go to 21, when the temperature go to 20. I feel hot when the temperature go to 24, 25, 26, etc. So different persons or different different students, they have different people, so they have different interpretations about the number. In computer science, we always use up absolute number, for example 23 for the temperature, etc. So this is not perfect and is not close to a human thinking. So what we are going to right now to learn is, hey, not only a square 23, yes, below 23, no, we are not going to do so. We will have something called sigmoid function. So suppose that here, the sigmoid function, the middle part is 23, right? When it's 23, so when it's about 23, more and more when more people think that it's hot, okay? Maybe 23, you will say that it's not hot, right? 23 is not hot. But you go to 25, 30, 45. So definitely you will feel that all the people will agree it's hot. So we have a gradient increasement about accepting this part. Okay. And then similarly, someone will say 23 is not cold, so it's not hot. So I will say it's not it's hot, it's not hot. So I will say that 18, 19 or something. If it's over 15 degrees, then I will say it's hot, something like that. So everyone they have the acceptance value will be more or less different, but honestly they have the threshold. Okay, just like when it's over 40 or over 30, all the people will say it's hot, right? So this kind is called activation function. So when you have the activation function, you change the linear equation to a nonlinear approach. Okay, so the activation function, this one, we call it sigmoid. Sigmoid here, sigmoid. The equation is like that. Okay, and then you have different kinds of the activation function. You have the tangents, we have the ReLU, we have the most likely the maximum value. So the slope will be changed according to the increase of the threshold, etc., etc. So those are the nonlinear parts of the neural network. So it makes us not so robotic, not so programming, not so 23, and then I will accept. Not 23, then I will not accept. Not so rigid. So that is the linear part of the linear part of the neural network. But don't worry, here you just understand, hey, I have the activation function. Why I have the activation function? Because we guys are human. We want to simulate the thinking of human. And human is not programming, it's not robotic, it's not 23, it's hot. Not below 23 is cold. We are not this kind of thinking. So we have the gradients. Okay, we have the gradients. And how we modify the gradient is here. No need to remember the mathematical representation of sigmoid, of tangent, etc. No need to remember. So yeah, that is the things that handled by computer science guy. And for all this kind of mathematics, when you have learned inside your high school, inside your secondary school, now you know that, hey, I have the application area and it's here. Okay, not all the students they have the ability to use the high school mathematics, but honestly, those are the preparation when you want to step into different area. For example, here when you want to move to PhD or when you move to a research level, so you have to understand this kind of mathematics. And all the mathematic tools, they have the representation, they have the meaning behind. And yeah, in higher education, you are going to study this kind of meaning, this kind of things.